Welcome to Algebra 1, Part 1, Section 3.4. Find slope and rate of change. Slope is the ratio of the vertical change, which is the rise, that's up and down, to the horizontal change, the run, that's left and right. Slope is going to be designated by the letter m. So m equals the slope, which is rise over run, that's a ratio. Rise is up and down, that's change in y, or delta y over delta x. X is left and right. So again, change in y over change in x. Now this here at the end is going to be known as our slope formula. And this is something we need to know. So the slope formula, m equals y2 minus y1 over x2 minus x1. What does that mean? Well, we're given 2 points. One point is going to be as an x coordinate and a y coordinate. We're going to call that x1, y1. The other point is going to have an x coordinate and a y coordinate. We're going to call that x2, y2. We're going to do some examples in a second. Doesn't matter which one you call x1 and y1 and x2 and y2, as long as whatever 2 you start with for the y, whatever y coordinate you start with, you have to start with the x coordinate from the same point. So that's why we usually say it as y2 minus y1 over x2 minus x1. So this up and down is the difference when you subtract between the 2 y coordinates. That's our rise. How much did I go up? Hey, that's the difference of the 2 y coordinates. And how much did I go left and right, or how much did I run? That's the difference in the x coordinates. So let's take a look at our slope formula as we use this in a few of our examples. Example 1. Now, I didn't draw this line going on forever, but we know lines can go on and on forever, and that's fine. Okay. So we're given 2 points. Negative 4, 2. I'm going to call that my x1, y1. 2, 6. I'm going to call that my x2, y2. I want to find the slope. So I know the slope is equal to y2 minus y1 all over x2 minus x1. What is my y2? That's the y coordinate for my second point. So for me, that's this one, 6. Minus the y coordinate from the first point. That's going to be 2. And now let's start with the x coordinate for x2. I'm going to start with the x coordinate from the same point that I started with for the y coordinate. That's 2. 2 minus, and then the first x coordinate is going to be negative 4. What is my slope equal to? 6 minus 2 is 4. 2 minus negative 4, we know to change subtraction to addition, add its opposite. So we get 6. So our slope is 2/3. Okay, a couple things I should notice. The slope is positive. I should start to notice, hey, what happened with this line? Oh, it went, as I look at it left to right, it goes up. And that's going to make a little more sense later on. Okay, let's look at another example. Example 2. Change my pen here. So once again, we want to find the slope. And again, this line, I didn't draw it like this, but this line can go on and on forever. So there's 1 point, and this line can go on and on forever down here. That's my second point. So I call my first point 3, 5, my second point 6, negative 1. So I want to find the slope using our slope formula. Which again, what is slope equal to? Change in y over change in x. We know this is y2 minus y1 all over x2 minus x1. So now I just substitute what I know. What was my y2? Okay, that's negative 1 minus, what's my first y coordinate? That's 5. All over the x2, so I choose the x coordinate from the same point that I started with for the y coordinate, 6. I'm going to get 6 minus 3. Now it's simplify both the numerator and denominator. Change all subtraction to addition. Negative 1 plus negative 5 is negative 6. 6 minus 3 is 3. And again, I can change that to plus or minus. That's going to give us negative 2. And again, I can call it negative 2 or negative 2 over 1. Same thing. And again, what do we notice? As I read my line left to right, I go down. So, a negative slope means my line goes down. And again, we'll clarify that in a little bit. Example 3, once again, find the slope. And I don't have it here, but this line could go on and on forever. I'm just drawing the segment to start with. But within this line, I have 2 points that are given to me, so I can find the slope of that line. So my first point is negative 2, 4. My second 2 is 4, 4. I should notice this to be a horizontal line. I'll talk a little bit more about horizontal lines in a little bit. Slope equals change in y over change in x. y2 minus y1 all over x2 minus x1. So my y2 is 4. Minus y1 is also 4. Uh-oh, 4 minus 4, that's going to give me 0. And then here my x's, I start with this one, 4 minus negative 2. We can change that, add its opposite. 4 plus 2 is 6. Hopefully we recognize that 0 divided by 6 is still 0. So my slope is 0. When we think about that, I don't rise at all, but yet I continue to run. So all horizontal lines are going to have a slope of 0. And we should also notice that all horizontal lines are written as y equals some number. And my example is y equals 4. How do I know that? Because this y coordinate's 4 and this y coordinate's 4. And any point on that line is going to have a y coordinate that's 4. Okay, so horizontal lines have a slope of 0. Let's do this example. Let me change my pen to blue. So we now have a vertical line up and down. Vertical line, 2 points, 1 point's 3.5, the other point's 3.1. Let's find the slope. Slope equals y2 minus y1, that's a change in y's, all over the change in x's. Change in y's, I'm going to start with the 1 minus 5, all over change in x's, 3 minus 3, this is going to become 1, add its opposite, 1 plus negative 5 is negative 4. Uh-oh, I get 0 in the denominator. We cannot divide by 0. This is undefined. Sometimes we'll write that as an infinity symbol, but undefined. So what we find out is all vertical lines have an undefined slope. So we rise a bunch, but we don't run at all. And all vertical lines are represented by x equals a number. So in this example is x equals 3. Notice x is 3, x is 3. Okay, so that gives us a lot of information. And so now, how do we classify lines? Well, any line that looks like this has a positive slope. So any line that rises from left to right. And this is when slope is greater than 0 or positive. Any line that looks like this, as I read it left to right, is going down. That is a negative slope. The line is falling. And this is, slope is less than 0 or negative. Any line that goes exactly left and right is a horizontal line, which is always going to be equal to y equals some number. Sorry about that. And this is where the slope equals 0. Oops. Let's see if I can delete that. Sorry about that. Almost done here. And that we said was, change the pen back. Slope was equal to 0, so horizontal lines always slope equal to 0. And any line going up and down is a vertical line. Sorry about that. Vertical line, x equals some number, and slope is undefined, because we cannot divide by 0. Okay? So that's a lot of information. And then the next thing we're going to build off of slope is getting into rate of change, where you're now just comparing a change in one quantity to a change in another quantity. So an example might be, and you guys have done this forever, 30 miles per 5 hours. So there's a quantity divided by a quantity. We don't write the per in there. The fraction is understood to be there. So again, we're comparing rate of change. And so now what we're going to do is we would reduce that to 6 miles per 1 hour. Okay, and it might be dollars per hour, miles per gallon. There's a bunch of different ways to do rate of change. So, and that'll tie right into the slope because we're doing a comparison of two quantities now, rather than change in y over change in x. In this case, we're doing change in miles per change in hour, and we usually want it as the bottom one as a unit rate. So 1 hour or one, I made $10 per hour rather than saying I made $30 per 3 hours. Okay, so that's what we'll look at. Thank you very much.